So the next topic is Joule, Thomson, Kelvin experiment. Joule, Thomson, Kelvin effect. So before going into this topic, we must know about some fundamentals of thermodynamics, that is thermodynamic laws. According to the first, there are basically three laws of thermodynamics. According to the first law of thermodynamics, it is based on, it is basically conservation of energy, and it was formulated by scientist Joule. According to it, when heat energy is added to a system, it is the sum of heat energy added to a system is the sum of change in internal energy, plus work done by the system. So mathematically, heat is represented as Q equal to del U. Internal energy is represented as U, and the change in internal energy is del U plus work done. So according to the first law of thermodynamics, heat given to the system is equal to change in internal energy and work done by the system. And second law of thermodynamics. This is first law. First law of thermodynamics. Now we will see second law of thermodynamics. According to it, heat never flows from cold to hot object. That is, heat always flows from hot to cold object. So heat never flows from cold to hot object. This is not possible. But this is possible only by doing some additional work by using engines, heat engines and heat pumps. So only by means of some by using engines, one can it can be possible to flow from cold to hot object by means of using heat engines or heat pumps. So naturally, spontaneously, heat only flows from hot to cold object, but spontaneously it cannot flow from cold to hot. For that you need to do some work by using engines. And third law is not necessary at this moment because it is all about entropy. So coming back to Joule Thomson Kelvin experiment, what is the necessity of this experiment? So this experiment, it all tells about compression and expansion of the gas molecules, and when you compress and expand gas molecules, what happens to its basic properties like temperature, pressure, volume, is all about is the mostly dealt in this Joule Thomson experiment. So origin of the Joule Thomson experiment is the scientist Joule. So Joule is the scientist, and on his name only the unit of heat is defined. That is Joule. Unit of heat is Joule. So initially, Joule started his experiment by using two reservoirs. And imagine that this setup is placed in a water bath. Reservoir 1 and 2, and these two are separated by means of a tap. By means of a tap or a valve. One end of the one reservoir is filled with high pressure gas. And another reservoir container is low pressure or vacuum or evacuated. So vacuum is there. Just imagine this experiment was conducted in the water bath. So both the reservoirs were in the water bath. So it means isolated from the environment. So he conducted the experiment adiabatically. So adiabatic, when he allows the compressed or high pressure gas to pass through the vacuum, that is allow it to expand, and the gas is allow it to expand adiabatically. For an adiabatic process, change in heat energy is zero. So it means no heat enters the system nor leaves the system. So internal energy will become zero. So the equation first law, according to the first law of thermodynamics, Q is equal to U plus PV, U plus work done. Here Q equal to 0. So U equal to minus. So here Q equal to 0. So when a gas is allowed to expand adiabatically, there is no change of heat. This heat either enters Heat never enters and leaves the system. So in this process, when a valve is opened, what happens? When a valve is opened, gas molecules starts to move from the region of high pressure to the low pressure, and after some time it occupies the entire system. Gas occupies the second container. So in this process, gas is said to be expanded. So del Q is 0, and according to Joule's experiment, this is all about Joule's experiment. According to Joule's experiment, there is no change in heat. He measured using a thermometer. He measured temperature of first vessel as well as second vessel, and both the temperatures are, he believed both the temperatures are equal, and there is no change in temperature. So del T is 0. Okay, del Q is already 0 because it is adiabatic expansion, and del T is also 0. Now, so del T is 0 means there is no change in internal energy. So del U is also 0. Del U is also 0. So according to the first law of thermodynamics, when del Q and del U are 0, 0 plus 0 equal to 0 plus, so work done is also 0. Work done is also 0. So according to the Joule's experiment, there is no change of temperature when a gas is allowed to expand from the compressed zone to vacuum zone under adiabatic condition. Keep in mind, adiabatic condition means no heat enters the system nor it leaves the system. Now, this setup is theoretically possible. This idea of Joule's no change of temperature is only possible for only possible for ideal gases. Ideal gas, or it is possible for theoretical. Theoretically, it is possible, but practically speaking, when you are allowed to compress a real gas and then allowed to expand it to a high vacuum region, its temperature will vary. That was experimentally proved by these two scientists, Joule as well as Thomson Kelvin. So Joule and scientists Joule and Thomson, they worked together to experimentally prove that del T is not equal to 0. In this process of expansion, there will be a change in temperature. Change in temperature is possible. They experimentally proved it. Okay. Whereas earlier, Joule observed del T as 0. Del T as 0. Okay. Now we will see the experiment. In this case, in the case of Joule-Thomson Kelvin experiment, they used a double walled glass pipe. They use a double walled glass pipe, and it is the reservoir 1 and reservoir 2 or container 2. So high vacuum is there in between the glass tube, glass walls. So high vacuum, and high reason for high vacuum is to conduct the experiment adiabatically. So heat enters, there is a porous plug. So porous plug is in between two reservoirs. I can use Joule Thomson's porous plus experiment, porous plug experiment. Alternatively, you can call it as porous plug. So here porous plug means there is a material called based on alumina. Alumina ceramic, porous alumina ceramic is used in between two reservoirs. Porous alumina ceramic is used so high pressure gas molecules are there, the one end. High pressure gas molecules. And here, naturally, we have one end is vacuum. So second reservoir is a vacuum. So first reservoir is fully filled with air molecules. So naturally, air molecules diffuses through the pores of the porous plug or alumina ceramic, and then gradually reaches the second reservoir. So diffusion takes place from first reservoir to second reservoir. So in the process of transportation, these gas molecules lost some of its energy, some of their kinetic energy as frictional energy via the alumina ceramic, pores of alumina ceramic, and then reaches. So in this process, internal energy of the system changes. So what is the internal energy? Internal energy is nothing but internal energy. U is equal to potential energy plus kinetic energy, and internal energy changes means its kinetic energy changes. So kinetic energy is nothing but the temperature. So whenever you speak about temperature, you are talking about kinetic energy of atoms and molecules. So kinetic energy is nothing but temperature. So you are going to measure temperature means you are going to see the kinetic energy of atoms and molecules in a system. So here, change in internal energy means kinetic energy decreases. So in this case, kinetic energy is high in the case of reservoir 1. Once it reaches the reservoir via porous plug after losing some of its energy, in this second reservoir, kinetic energy is reduced. Kinetic energy is reduced, and so there will be change in internal energy of the after expansion. So kinetic energy is reduced means definitely temperature is also reduced. If you measure the temperature in the first reservoir as T1 and second reservoir as T2, then T2, T1 minus T2 is not equal to 0. Okay, T1 minus T2 is not equal to 0. So the reason is it loses some of its internal energy. So when according to first law of thermodynamics, when Q equal to 0, Q is equal to U plus work. So change in internal energy equal to minus W. Change in internal energy is minus W. So negative of work is done here. That is, air molecules does work on their own. These air molecules does their work on their own in passing through the porous plug and expands in the reservoir too. So in this process, internal change of internal energy takes place. Because of the change of internal energy, kinetic energy of air molecules drops. Kinetic energy of air molecules drops. So what is the Joule-Thomson effect? So Joule-Thomson effect is when an air molecule is adiabatically allowed to expand, its temperature, change in temperature is observed. So when gas molecules or air molecules are allowed to expand, adiabatically expand, temperature drops. Temperature drop is observed. This is Joule-Thomson Kelvin effect. So there will be T1 minus T2 is not equal to 0. That is, you can write and this change in temperature T1 minus T2 is directly proportional to P1 minus P2, pressure in the first reservoir and pressure in the second reservoir. So alternative you can write dt is directly proportional to change in pressure and can be equated by applying Joule-Thomson coefficient mu. Joule-Thomson mu suffix Jt, Joule-Thomson coefficient into dP. finally you will get, you can write like this, dT by dP equal to mu suffix Jt, and the ratio is said to be Joule-Thomson coefficient. So now we will see what is the reason for this cooling. What is the reason for this cooling? So temperature of after expansion, temperature of the reservoir T2 is less than temperature of gas molecules in the reservoir T1. So what is the reason for the cooling effect? So reason for the cooling effect is heat is lost, that is internal energy is lost, so that kinetic energy is also lost, and in such a way temperature is also decreased. So when you in this process of Joule-Thomson experiment, there is a porous plug and now we will see work done for the expansion. Expansion and the compression, and it is the region of compression. And second reservoir is the region of expansion. So imagine that to understand the work done on both sides, imagine that you apply virtually you apply use a piston to compress these air molecules, and in the beginning the volume of air molecules on the left hand side is V1 and volume on the right hand side is V2. Of course, pressure on the left hand side is P1 and pressure on the right hand side is P2. Similarly, temperature on the left hand side is T1 and temperature on the right hand side is T2. Okay, now we are going to see the work done in compressing and expanding the gas molecules. So for that I use an integration. So integration of P2 P dV. Initially the volume in the left hand side is V1, and when a piston moves or compresses the air molecules, after a time piston reaches the porous plug, surface of the porous plug. So after a time, volume in the reservoir 1 is 0. And in the right hand side, initially imagine that virtually piston is present here. Piston exists on the surface of the porous, and when the gas starts to expand, it moves or pushes the piston towards extreme right hand side. You visually imagine there exists a piston. Okay, so initially, since a virtual piston is there on the surface of the porous plug, volume is 0. Volume is 0. Volume on the first second reservoir is 0, and after a time, piston is moved to the left side, right side. So volume will be V2. After complete expansion, volume will become V2. So now you can write P1 here. Why I have used minus sign means, in this case, volume is negative. That is, volume is decreased from maximum to minimum. So volume is negative, so I have used minus sign. And minus, since volume is 0, after a time, volume on the left hand side is 0. That is, piston moves to the surface. When the piston moves to the surface of the porous plug, volume will become 0. So this part, and pressure is also 0. 0 into 0, you will get. And here, on the right hand side, you will get, initially volume is 0 because piston is virtually on the surface of the porous plug, and pressure is also 0. 0 into 0 minus, after complete expansion, volume is V2. Now here it is positive volume, so I am not going to use a minus sign. So